Hello everyone, in this video I'm going to go over an alternate approach to modeling spring mass damper systems in Simulink. This time I'm going to use a transfer function instead of all those gain blocks. So the first thing we need for this model is our input, which is again a sine wave. The next thing we're going to need is our integral blocks, which are also called integrator blocks. The next thing we're going to need is our integrator blocks. And we're going to need two of them because we have a second order derivative. And we're also going to need an add block and a second add block to act as our looping block with a plus sign and a minus sign, which effectively makes it a subtract block. And I'm going to call it loop like we did in the previous function, in the previous model. So now that we have these blocks, we're going to add our scopes. Just like in the previous model, we're going to have 3 scopes. We're going to have our acceleration, our velocity, and our displacement. So now that we have these 3 blocks, we are going to add our transfer function, which is called with the transfer function block. When you click on this block, you're going to be able to add either a numerator, which by default numerator is 1, and in this model it's going to stay 1. But you can also add coefficients to the denominator. In this case, we are going to add 3 coefficients, 12, 53, and 96, representing the 3 coefficients in our derivative that we want to solve. I'm going to enlarge it so you can see the function. And we're going to put the transfer function here, right at the beginning of our loop. And we're going to connect our loop. And we're going to also connect it to our first integrator block, which we're going to call velocity data again. And then we're going to connect this integrator block to our second integrator block, which we're going to call position data. Now, we have these scope blocks. And we're going to add them to each branch of our data, like we did in the previous model. And then we have this add block. We're going to add our position and velocity data, like we did in the previous model. This is a necessary step in order to factor in the effects of the gains caused by these integration operations. And now that the model is completed, the last step is to add our initial conditions. For velocity, it was 0.001. For displacement, it was 0.005. And if we run it, as you can see from the data here, we get a gradually decaying oscillation. And if I bring up the data from the previous version of the model, which you can see here, it looks like we got a pretty close match. And that's all for this video. Thank you for watching.